2011 Canadian Open Mathematics Challenge, Part C. ABC is a triangle with coordinates A 26, B 00, and C 14, 0. Let P be the midpoint of AB. Determine the equation of the line perpendicular to AB passing through P. First, let's find the midpoint of AB, P. So that's just using the midpoint formula. 2 plus 0 divided by 2, 6 plus 0 divided by 2. And that is 1, 3. So that is the midpoint. And now we want to find the equation of the line perpendicular to AB. Well, first let's figure out the slope of AB. That's just rise over run. So that's going to be 6 minus 0 over 2 minus 0. And that is 3. So if a line is perpendicular, its slope will be the negative reciprocal of this. So the negative reciprocal of 3 is negative 1 over 3. So that's the slope of that line that we're trying to figure out the equation of. All lines have the equation y equals mx plus b. This is my m for this particular line. So it's really y is equal to negative 1/3 x plus b. Right? To figure out b, we just substitute a point on the line. And one of the points on the line is p, because the line passes through p. So P has the coordinates 1, 3, so substitute 1, 3 into this equation. When y is 3, x is equal to 1. And then if you solve for b, you get b is 3 plus 1/3, which is 10 over 3. And therefore, that equation is y is equal to negative 1/3 x plus 10 over 3. Part B, let Q be the point on line BC for which PQ is perpendicular to AB. Determine the length of AQ. All right. Let's move this up a bit. Q be the point on BC for which PQ is perpendicular to AB. Okay. So let's draw a very basic diagram. It doesn't have to be a masterpiece. This is my ABC, right? This is A. This is B, and this is C. So they are saying that there's some point on BC called Q. So perhaps, I don't even know, here maybe. And when you draw a line from Q to AB, to P actually, it connects to P, where P is the midpoint from the previous question. So when you connect that line, they're saying that this is a right angle. That's essentially what they're saying. And they want you to determine the length of AQ. So they want you to determine the length from A to Q, like that. Oops, that's not a good line. There you go, that's a better line. Okay, I think I can do this. All right, so, well, immediately I see a Pythagorean relationship here. PB, PQ, and BQ. Yeah, and I have all these points, right? P is 1, 3. B was 0, 0. They give that. And Q, Q we don't know. Yeah, Q we don't know. So Q I will have to figure out. But one thing I do know is that since C was 14, 0, that means that Q is on that line. So that means that the y coordinate is 0 for Q. So it's some x coordinate, but then 0. Okay, so that's good because that means there's only one variable. And then A was 2, 6. Okay, sure. This shouldn't be too big of a deal. All right, so the first thing is using this triangle, Pythagorean relationship, because that's a right angle, right? That angle is right. So that means that PB squared plus PQ squared is equal to BQ squared. Okay, so using the distance formula, PB would be 1 minus 0 squared plus 3 minus 0 squared under the square root sign. And then, of course, we're squaring that because it's PB squared. PQ, where's PQ? Ah, okay, got it. So 1 minus x squared plus 3 minus 0 squared, all under the square root sign. But then, of course, you're squaring that. And then BQ, 0 minus x squared plus where is it? BQ. Where's B and Q? Oh, 0 minus 0, right? Okay, that's easy. I'm just writing it out in the complete form. I don't want to do any shortcuts. I don't want to confuse you. Okay, now we can get to the nitty gritty here. This is 1 plus 9 plus 1 minus 2x plus x squared plus 9. And on this side, it just is x squared. So x squared is canceled, which is very nice. Put the 2x on this side, and this becomes, it looks like 20 to me. So that means x is 10. So this is 10, 0. Okay, now we just have to figure out AQ. That's pretty straightforward. AQ. This is the coordinates for Q. This is the coordinates for A. So AQ, 2, again, using the distance formula, 2 minus 10 squared plus 6 minus 0 squared, all under the square root sign. So that's minus 8 squared, 64. 6 squared, 36. So that looks like 100 squared. Square root, I should say. And that's 10. So AQ, the value of AQ is 10. See, there is a unique circle passing through points A, B, C. Determine the radius of this circle. So what they are saying is that there's a circle that kind of goes through the points A, B, and C like that. And we have to figure out the radius of that circle. Well, the good news is that we have a formula, very helpful formula, of such a scenario. If you have a circle and then you have a triangle inside that touches the circle at 3 points, then the radius is equal to the product of the sides over 4 times the area of that triangle. All right, so we have to figure this out now. Okay, well, A is this side, B is this side, and C is this guy right here. Now, the distances are easily figured out using the distance formula. So A, well, A is easy because that's just 14, because that's just the distance from 0 to 14 on the x-axis. B, of course, that is equal to that segment AC, and use the distance formula. So 14 minus 2 squared plus 0 minus 6 squared under the square root sign. And when you do this math, you get 144 plus 36, and that is the square root of 180, which can be written as 3 root 20. And then C is the line segment AB, and again with the same sort of formula, 2 minus 0 squared plus 6 minus 0 squared under the square root sign, which is 4 plus 36 squared, which is root 40, and that is 2 root 10. Okay, great. So we've got the 3 up top. So we got A, which is 14, plus B, which is 3 root 20, plus C, which is 2 root 10. Okay, then we got 4, and then we have to now put in the area of the triangle. Okay, the area of the triangle, it shouldn't be too bad. First, I need to draw a height. So this green line I will call H, perpendicular to the base. So the area of that triangle is 1/2 base times height, like any triangle. The base is this right here, which is just 14. And the height is H. But H, if you look at this carefully, it's just 6, because you're going from the x-axis up to the point A. And the y-coordinate of point A is 6. So that's it. So easier than I thought, actually. So 6 divided by 2 is 3, so this is 42. So I stick that 42 here. And then now, I guess you just crunch out these numbers. Let's see here. I think that'll be 84 over 168. And that's root 200. So that's 1/2. Actually, yeah, 1/2. And then 100 times 2, so 10 root 2. Yeah, 10 root 2. So that just looks like 5 root 2. So there you go. The radius of that circle is 5 root 2. Charlotte writes a test consisting of 100 questions where the answer to each question is either true or false. Charlotte's teacher announces that for every 5 consecutive questions on the test, the answers to exactly 3 of them are true. Just before the test starts, the teacher whispers to Charlotte that the answers to the first and last questions are both false. Determine the number of questions for which the correct answer is true. Okay. Well, let's say you have question number 1, question number 2, 3, 4, 5, like that. And then question number 6, 7, 8, 9, 10. And then eventually dot, dot, dot. You're going to get down to the very last ones, which would be, 95, 96, 97, 98, 99, and 100, right? Because there's 100 questions. Yeah, 100 questions. So each consecutive group of 5, so for example, these 5, dot, 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 all the way down to the last 5, which is these guys, have 3 true in them. So this has 3 true. These 5 have 3 true, and these 5 have 3 trues. 3 trues. So there's 100, and that would mean there's 20 groups of 5. And in each group of 5, there's 3 trues. So the total number of trues is 20 times 3, which is 60. So 60 true, and therefore the other 40, since there's 100 in total, would be false. So 60 questions would have the answer true, and 40 would have the answer false. Part B. Determine, what is the correct answer to the 6th question on the test? Okay, interesting. Well, the fact that the teacher says that the first and last questions are both false, let's just use that. So that's very helpful. So the first question is false, and the last question is false. Okay? So that means that of these remaining 4, those 4, 3 of them are true. That has to be according to the question's information. So, and of course, there's several ways of doing that. There's true, 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 false. That's one way. There's true, true, false, true. There's true, false, true, true. And then I guess the other way would be to make the first one. So it'd be false, true, true, true. These are the scenarios to satisfy the fact that 5 consecutive questions have at least 3 trues in them. And in all of these, if you look at the 6th question, it has to also satisfy that 5 consecutive have 3 trues. So therefore, in each of these, this must be an F in order to satisfy that the questions 2 through 6 have 3 trues in them. 3 trues like that. The only way that's possible is if question 6 is false. So that's basically the explanation. All right, down to the last one. Explain how Charlotte can correctly answer all 100 questions on the test. Okay. So let's, I guess we'll just leave this in for now because I think it'll be helpful. In part B, we concluded that question number 1 was false and question number 6 was also false. Now, by that same logic, we can extrapolate, and find out that if question N is a certain answer, question N plus 5 will have the same answer. Will have same answer. And basically, we use the same logic that we did here. Nothing new, nothing fancy. So, for example, we concluded that question number 1, question number 6, and every successive fifth question is false. And you can do that, like I said, with the same logic here. So you can show that question 1, 6, 11, 16, dot, 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 all the way up until you get to the last ones, 91, 96, have the same answer. And that we have also shown that is false, that the answer is false to those questions. And then what you do, you say, okay, well, that's great. What about question 2? Question 7. If this is true here, then question 2, 7, and every fifth one, 12, 17, dot, 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 all the way to 93, 98. That will also have the same answers. And we just proved that it can be a few different scenarios, right? Here's question 2, and you notice like sometimes it's true, but then it can also be false. So we're not 100% sure what it is always. Okay, no problem. We can find out that at the end. Let me just write out the next few sets, which is 3, 8, 13, 18, dot, 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 until 94, 99. And then I want the one that starts with 4, that'll be 4, 9, 14, 19, dot, 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 until 94. 94, 99. Sorry, I think this should have been 92, 97. Let me just fix that. Sorry about that. And then the last one is the one with the 5. 5, 10, 15, 20, dot, 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 all the way till 95 and 100. Okay, so now we will be able to fill all this in. Notice this one here, we're told that the last question is false. So this is false. So all of these guys are false. So that means question number 5 is false, question number 10, question number 15, 20, because all of those are in the set. And according to this principle, they all have the same value. So question number 100 is false, question number 5 is false. So now, just look at the first set. Question number 1 was false, question number 5 was false. So the only way for this to work and for every 5 consecutive questions on the same test to have the same answer is for these ones to be true. And if you did that, then everything will match. The entire pattern from 1 to question 100 would satisfy the conditions of the question. Let n be a positive integer. A row of n plus 1 squares is written from left to right, numbered 0, 1, 2, dot, 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 n, as shown. 2 frogs named Alphonse and Beryl began a race starting at question 0. For each second that passes, Alphonse and Beryl make a jump to the right according to the following rules. If there are at least 8 squares to the right of Alphonse, then Alphonse jumps 8 squares to the right. Otherwise, Alphonse jumps 1 square to the right. If there are at least 7 squares to the right of Beryl, then Beryl jumps 7 squares to the right. Otherwise, Beryl jumps 1 square to the right. Let an and bn respectively denote the number of seconds for Alphonse and Beryl to reach square n. For example, A40 is 5, B40 is 10. Determine an integer n greater than 200 for which bn is less than an. So let's explain this question first. Why is A40 equal to 5? Okay, well, A40 equal to 5. What does that mean? That means Alphonse to jump through 40 of these squares takes him 5 seconds. Well, why is that? Okay, let's talk about this. He starts, there's 40 jumps he has to make, or 40 spaces, whatever they're called. They're called spaces, right? Squares, they're called squares. Okay, so there's 40 squares he's got to go through. The rule states that he jumps 8 if there's at least 8 squares. Well, there's 40 to begin with, so he can jump 8. Once he jumps 8, there's 32 left, right? So he can jump another 8. Then there's 24 left. He can jump another 8. There's 16 left. He can jump another 8. There's 8 left, and he can jump another 8. So each jump takes 1 second. So this was the first jump, second jump, third jump, fourth jump, 5 jump. Each jump took 1 second. So the total number of seconds if you add up these guys, is 5. So that's why A40 is equal to 5. Now let's talk about B40 is 10. This B refers to Beryl. Her rules are a little bit different. Not exactly, but they're similar. She starts off with 40, but she has the ability to only jump 7 squares, right? 7 squares. And that is only if there's at least 7 squares remaining. So when she first starts off, there's 40. She jumps 7. Okay, now there's how many left? 33. She jumps another 7. 26 left. She jumps 7. There's 19 left. She jumps 7. There's 12 left. She jumps 7. Now there's 5 left. Now once there's 5 left, she cannot jump 7 anymore because there's not enough squares. So then she has to do this one at a time, 1 square at a time. So she's going to jump 1, 1, 1, 1, 1 like that. So how many seconds did it take? Each jump took 1 second, right? So 1 second, 1 second, 1 second, 1 second, 1 second, 1, 1, 1, 1, 1. So if you add all these up, you get 10 seconds. And that's why B40 is equal to 10. So, I mean, I probably you figured this out already. You didn't need me to walk you through it, but, you know, for those of you who are a bit confused about the opening stem, that's the explanation. So now, what do they want? They want this guy here. Bn is less than An. So we can plug in a whole bunch of numbers and see, but that's going to take forever. So we have to have some sort of a system here. Okay, based on this explanation, you can, in your own mind, figure out an equation. And here's the equation. That An would be equal to n divided by 8. We take the integer value, that's what that symbol means, plus n minus 8 times the n over 8 integer value. N divided by 8. So for example, when n was 40, what you did was you took 40 divided by 8, and that gave me the number of jumps that he takes that are 8 in length. And then what's left would be the original number, which is 40 in this case. I got to put in 40, minus that number divided by 8, which is 40. Take the integer value, and you have to multiply that by 8. So in this case, first you figure out how many of these big jumps does he take, and that's easy. You just take the number divided by 8, and in this case it's 5. But we have to make sure that we take the integer value. In this case, it is the integer value already. And then what you have to do is say, well, what's left over? What's left over is 40 in this case, if we're using n equal to 40, and 40 divided by 8 is 5, and that's already an integer. So this looks like it's 5 plus 40 minus 40, which is just 5. So that's why A40 is equal to 5, which is what they gave us. And in a very similar way, you can figure out the formula for B40, and it's really just a little bit of thinking. There's no magic here. There's no like a magic way of doing this. So Bn in a very similar way is going to be n over 7, the integer value of that, plus n minus 7 times n over 7. So for example, when n is 40, this would be 40 over 7, the integer value, plus 40 minus 7 times 40 over 7. So 40 over 7 is 30, well, is 5 point something, but we just worry about the integer value. And then this is 40, of course, and then minus 7. 40 over 7 is 5 point something, but when you take the bracket, it's the lowest integer, so that'll be 5. So this looks like 5 plus 40 minus 35, which is 5 plus 5, which is 10. So that's why B40 is 10. So these formulas, I hope you don't get too intimidated that, you know, there's no way I would have been able to come up with this. I think it's not that bad. A little bit of intuition, plugging in some numbers to see that it actually works out. Okay, now that we have those two formulas, let's put it back into there and see what we get. So that means that Bn, which is n over 7 plus n minus 7, n over 7 bracket, we want it to be less than an, and that is your n over 8 plus n minus 8 times n over 8. So this is what we want. Okay? So this is basically our Bn is less than an formula. Okay, great. So now let's work with this here. The n's cancel on both sides. This looks like it becomes minus 6 n over 7 less than minus 7 n over 8. And then that means that if you get rid of the negatives, this becomes 6 n over 7 is greater than 7 times n over 8 bracket. Okay, great. So this is what we boil it down to. Now we have to figure out values of n that would satisfy that. And I think they just want any such value as long as n is greater than 200. They want determine an integer n greater than 200 for which Bn is less than an. Okay, so as long as I get one value, I've correctly answered the question. Okay, so now how do I get one value? I guess you can brainstorm this, but let's think of a system here. N is most likely going to be divisible by 7 and 8, right? It doesn't necessarily need to be, but it is possible. So n is going to be some sort of a multiple of 7 and 8. So 7 times 8 is 56, right? But it doesn't necessarily need to be. It could be a multiple of 8, or it could be a multiple of 7. So n equal to 56k plus 7, where k is some integer, is a very reasonable substitution to make, and it will help us in order to figure out what n is. So if I make that substitution, this becomes 56k plus 7 over 7, and this becomes 56k plus 7 over 8. And let's see here, this becomes 56 divided by 7 is 8. So this becomes 8k, and then 7 divided by 7 is 1. This becomes 56 divided by 8 is 7, and then I have 7 over 8. Now, since k is an integer, this is already an integer, so this is just going to be 6 times 8k plus 1. But 7k plus 7 over 8, that is a fraction. So when you take the lowest integer value, it's going to be just 7k. So that's what it boils down to. Now this becomes 48k plus 6, and this is 49k. So that means this would be that 6 is greater than k. Okay. So k is an integer, and k is a positive integer, I believe. Yeah. So good news is we don't have that many to choose from. So let's try k equals 5 and k equals 4, and let's see what we get. When k equals 5, that means n, which is right up here, is equal to 56 times 5 plus 7, and that's 287. And that is indeed a value of n greater than 200, for which b of n is less than a of n. When k is 4, we have n is equal to 56 times 4 plus 7, and that is 231. So there's another one. There's another value of n, and so on. So you can find values that are greater than 200, and we found 2. And I think that's it. I think once you go down to k equals 3, it would not be greater than 200. So those two will satisfy the question. Let f at x equal x squared minus ax plus b, where a and b are positive integers. Suppose a is 2, b is 2. Determine the real roots of f at x minus x and the set of real roots of f at x minus x. F at x minus x. Well, f at x is x squared minus ax plus b minus x. Well, the values of a and b, they already told me, are 2 and 2. So there you go. This is x squared minus 3x plus 2. And we want the roots, so set that equal to 0. And I think this factors x, 2, 1, minus, minus. So therefore x is equal to 1 or 2. So there you go. Now we've got a little bit more challenging. They want you to find the roots of f at x minus x. Okay? So we've got to substitute this in. So f at x, which is x squared minus 2x plus 2 minus x. And then substitute this into here. So that's going to be x squared minus 2x plus 2 all squared minus 2 times x squared minus 2x plus 2 minus x. Okay. Expand and collect like terms. I'll let you guys do that. X to the power of 4 minus 4x third plus 6x squared minus 5x plus 2. And then now factor. And you guys can do that. Long division. You can get at x minus 1. And that will allow you to factor this into x minus 1. And on this side, it'll be 3x squared plus 3x minus 2. You can factor again from this guy. And when you do, you can get an x minus 2. And then that will relieve x squared minus x plus 1. And then we want the roots, so set that equal to 0. Well, it's obvious that the roots are 1 and 2 because this does not have any real roots. No real roots. Because try doing the quadratic formula. You'll notice that the discriminant is less than 0 if you do the quadratic formula. So therefore, again, the roots are just 1 and 2. Part B, determine the number of pairs of positive integers a, b with a and b between 1 and 2011 inclusive, for which every root of f at x minus x is an integer. Okay. So first of all, they are giving us the same formula, but no value is given for a or b. So I've got to figure this out. So this is f at x squared minus ax plus b minus x. And therefore, this is x squared minus ax plus b all squared. Minus a times x squared minus ax plus b, and then plus b minus x. Okay, so expand all this out, collect like terms, blah, blah, blah. And when you do, you get x to the power of 4 minus 2ax cubed plus a squared plus 2b minus a x squared minus 2ab minus a squared plus 1 x plus b squared minus ab plus b. Okay, so now we need to factor this. And when you factor, you will be able to get x squared minus a plus 1x plus b. And then the other factor will be x squared minus a minus 1x plus b minus a plus 1, like that. Okay, so in order for these to have real roots, or roots that are integers, so roots will be integers if the discriminants are perfect squares. Discriminants are perfect squares. So let me refresh your memory in case you're wondering what that means. If you recall, if you do a quadratic formula, x is equal to minus b plus or minus the square root of b squared minus 4ac. all over 2a, right? You guys remember. Well, this is the discriminant right here, what's underneath the radical sign. If that discriminant is not a perfect square, then you end up with some sort of a radical, right? You get a square root. But if it's a perfect square, then the radical would just make it into an integer. So that's what we mean by discriminant. So b squared minus 4ac must be a perfect square. So let's explore that. So for the first one, b squared minus 4ac is a plus 1 squared minus 4 times 1 times b. And that is a squared plus 2a plus 1 minus 4b. For the second one, that is the discriminant is a minus 1 squared minus 4ac, which is b minus a plus 1. And when you expand that, that becomes a squared plus 2a plus 1 minus 4b plus 4. Notice this and this are very similar. They are basically the same, except that if you compare them, they differ by 4. This is the same as this, and then you just add on a 4. So both of these have to be perfect squares, right? Can you think of any two perfect squares that differ by 4? There's only one such possibility. That one is 0 and the other is 4. Those are the only two perfect squares that differ by 4. So that's what we have to go with. All right, so that means that a squared plus 2a plus 1 minus 4b is equal to sorry about that. This, I believe, should have been a negative. Yeah, a good thing I noticed that. So therefore, that means this is 4 and that's 0. Okay, good thing I caught that, and sorry about that. So this is 4 and this is 0. Okay, no big deal. So now this means that this guy right here is equal to 4. So there we go. And then we can kind of figure this out from there. Okay, so if that's the case, we can factor this. A plus 1 squared, and this on this side would become 4 times b plus 1. Now, this is a perfect square, right? So this is a perfect square, so that means b plus 1 must be a perfect square as well. So b plus 1 must be a perfect square, so I'll call it m squared. So therefore, b is equal to m squared minus 1. So this is very important. Now I need something for a. Going right back to here, a plus 1 squared is equal to 4b plus 1. But b is m squared minus 1. So I'll substitute that in. So this means we have a plus 1 squared is equal to 4m squared. Take the square root of both sides. We get a plus 1 is equal to 2m. Therefore, a is equal to 2m minus 1. Another very important finding. So now we go back to the original question, which basically said that a is between 1 and 2011. Now I just figured out that my a is 2m minus 1 and my b is m squared minus 1. So basically I have to figure out how many values of m does this work for. Okay, let's see. When m equals 1, when m equals 2, when m equals 3, and so on. And eventually I'll get to a value that is outside of that range. When m equals 1, these numbers become 1 and 0. Well, that's not in that range, so that's no good. When m is 2, we have 3 and 3. That's good. When m is 3, we have 5 and 8. That falls between 1 and 2011. When m is 4, we get 7 and 15, and so on, right? And eventually, you'll get to a point where they won't be in the range anymore. 43 still falls in the range. It'll be 85 and 1848. M equals 44, I believe, is also in the range. It's 87 and 1935. But then when you use m equals 45, That's when it falls out of the range. It becomes 89 and 2024. So no good. So the only ones that are in the range that is here are the ones where m equals 2 to m equals 44. And that would be a total of 43 such values of m. And for each value of m, you get one pair AB. So therefore, that means there are 43 pairs AB that satisfy the conditions of the question.